here we go. Okay, so today we're going to focus mostly on this and this. This we're going to save for tomorrow. That's called, what's that called again? This one? Reciprocal. We're going to save reciprocal functions for tomorrow. Today we're doing absolute values of functions, and you can either absolute value the y of the function or absolute value the x of the functions. And let's start by just doing one of these old, here's a point, here's a really complicated function. Change that 6, 2 into the new point. This is just total review. Stuff you're supposed to already remember how to do. Hint, the 6 is the x, and it has to do with the inside here. That's where the x should be. F of x, you know? So that goes with this. Give it a shot without my help, and then I'll show you how. Because it's a review, it's better for you to try it first. So I would set, since this is the x part, you know, f of x, this part right here is x, 6 equals negative 3 parentheses 2 minus 4x, dividing both sides by negative 3, and I get negative 2, 2 minus 4x, subtracting 2 from both sides. A lot of chances to make little algebra mistakes, and I could be doing it too and not even noticing it, but it feels right so far. Cancels. X equals 1. Raise your hand if you had x equals 1. Yay, okay. Then the other part, which is where I have obviously y. And that's this part right here. That's my y. And it goes in where all of this was, where the whole f of x thing was. Another way to think of it is the stuff on the outside, which I will highlight in red, this and this and this are the things on the outside. And so I have to do them to the y. So I'm going to take this and say 9 minus 5 times that f of x is y. And y is negative 2. And then plus 7. So that's this same exact equation, except I stuck this in where f of x was. And f of x is the y, so there we go. Okay, so now I got 9 plus 5 times 2 is 10, plus 7 is 19, plus 7, which is 26. Who had 26? Nice. Then I got 1 comma 26. If you think I'm wrong, please say something, because I could have made a mistake. And you've seen it before, so. All right, cool. Then you will hopefully update on that kind. This one, it just might take you a minute to figure out what am I asking you to do. If this is the x and this is the f of x, then what is the absolute value of the f of x? Somebody tell me what they think should go in this box right here. Just say it if you know it.
36.
36. Because the absolute value of 36 is 36. Okay, next. This one's absolute valuing the inside. It's absolute valuing the inside. It's absolute valuing the x. Here's the x, which was negative 3. Now x is going to be positive 3. So if you had written f of positive 3, I would have actually been like, geez, should I give it to him? Because it's kind of right. You absolute valued the x. But then who sees something that's even better I could have written? I'm going to give it a second. Instead of writing f of 3, there's a better answer than that. 2 people have seen it now. Up to 3. How are you supposed to know what f of 3 is? Jack?
0.
Why?
Because on the right side says f of x when x is 3.
Here's when the x was 3, f of the x was 0. So apparently f of 3 is really 0. So I should have really put a 0 here. You see what's going on here? Okay, 1 over f of x. Well, in this column here, f of x is 36. So 1 over that, 1 over 36. That's it, done. Everybody try to just answer this column right here. The one I just circled in blue, try to do those without my help. I'll pause for a second. Then we'll give it a shot here. So if I wanted to do absolute value of the f of x was 1. So the absolute value of that is 1. Now I got to absolute value the x and then do f of that. F of this guy is the x, so I could say f of negative 2, but it's the absolute value of that. So the absolute value of negative 2 is 2. So that's f of 2. And I can look over here and find the f of 2, and it turns out it's 9. So 9 is the best final answer for that one. How many of you caught that? All right. Then last but not least, 1 over f of x. F of x is 1. 1 over 1, which is 1. 1 over 1 equals 1. All right. I think if you've got that, you've got the intro part to figuring out these absolute values. Let's move on. So this is a really critical slide, but I've already talked about it. Let's see if you remember it. If I said x squared equals 16, how would you solve that? What would be your first step? Just say it if you know it. Square root. Do. Everybody do that and tell me what you get. It'll hurt me, but I know some of you will have said x equals plus and minus 4 because you think that square roots have 2 answers, and you're wrong. And because you think that the square root of x squared is just x, and again, wrong. So if you, on the other hand, said that the square root of x squared is the absolute value of the x, does that ring a bell in the context of today? We're doing lots of absolute values, right? Okay, and then the square root of 16 is 4, then I'd say you were perfectly on track. And then how does the question end? You can split this absolute value into 2 things. X equals 4 and x equals negative 4. You might be like, but it still comes out plus and minus 4. But the problem is, if you don't get that this is an absolute value, and today's all about absolute values, that would be kind of sad if you think this skips over absolute values. Okay, all right. So if we looked at the graph of this, after you took the square root of it, and you just graphed that, it would be identical to this, because that's what the answer is. This graph and this graph would be exactly the same, because the square root of x squared's graph is an absolute value, and that looks like a V shape. Okay. Now, what would this have started as? Well, it was started as x squared equals 16, and then we were just solving it. That's how this all started. But would you agree that part of your answer when you do this is that you can take the square root and say that it's just x? Because you're going to break it into 2 equations, x equals this and x equals that, right? So let's explore the difference between y equals x, which looks like this, and the absolute value graph. This is the graph of y equals x. This is the graph of y equals the absolute value of x. Did we, when we take this and then do this to it, do you get we absolute valued the function? When we absolute valued, we put absolute value bars around the x. When you absolute value the x values, any x values that are negative, hint, these guys, those are the ones where the x was negative, those had to change because we absolute valued them. So the x's that were negative became positive. And they went up here instead. Do you see how this part goes away? And my graph just kind of changed from a straight line to a V shape. All right. So I don't like this next part. I think the next part I should do, I'm going to slide this over and help you understand this first. You've seen me do the baseball cap function before. Like that. It is a function. Actually, let's make this more straight. It is a function, and I'm going to change it to red here. Why is it a function? Because it passes a vertical line test. And you've seen me use this when I did the inverses. Well, today, it's not inverses, and we're not doing reciprocals yet. We're doing absolute values. But if this was the function, if this was f of x, what would it look like if I did the absolute value of the whole function? Did I just absolute value the x's or the y's? With that blue one that I just wrote, did I absolute value the x's or the y's? Yes. The y's. Do you see any part of my graph that has negative y's? Yeah. I'm going to highlight them. Grabbing a highlighter tool. Would you agree in this area, the y's are negative? All of those. You see what I mean? All of those y's were negative. They were below 0. So here's what your graph would look like when you were done. Absolute value of something takes negative numbers and makes them positive. You could almost say this got like reflected up there. This got reflected up there. My final answer, I will draw underneath it. Here's what it would look like. And where it would have gone down below, it's going to bounce up. There. I absolute valued the function, the whole function. What's the other way to absolute value a function? Yes?
Just absolute valuing the x values?
Yes. I'm going to show you that next. All right. So let's get a different parent function. Let's get a whole new, so get yourself to a new spot and make this guy. We'll make it like a mountain range. That's going to be f of x now. And before we do the new kind, I'd just like to do the other kind one more time, and then we'll just erase it quick, just to see if you really get it. Do you get, how would this look different if I did this? F of x, but with bars around it. Write it right on the same graph. I'll take a volunteer. What part needs to change? Tyler.
Just the part that's below the x-axis.
What's special about these guys here? Why are you picking on them?
Because the y value is negative.
Their y values are negative, and we just absolute valued them. So where does it go?
Reflected across the x-axis.
So it's up there. And then the blue part plus the red part that I just moved up there, that would have been your answer. Raise your hand if you had that one right. Okay, cool. Do you get most of the function isn't affected? Why? Because most of the function had positive y values. All right. So now I'm going to go to the next level. What if, in green here, I do f of the absolute value of x? Notice I just absolute valued the x values. Now you're going to think that this is going to work exactly the same as the other ones, but it's not. But at least this much should make sense to you. If I absolute valued the x values, only x values that were negative would even care. Do you get x values that are positive and you absolute value them? They just stay the same. So where do we have any negative x values? I'd like you to highlight it on your iPad. You can unhighlight it in a second. Highlight where are the negative x values. Just like fill it in with a little color. Where are the negative x values? If I were you, I would get that old one off the screen, so we just have the blue one like I have right now. Get your old answer off the screen, you know, where we reflected it up. Because you need a good example of just this kind of reflection. All right. Would you agree that this is the area where the x values were negative? Do you get that that's the part that has to change? Okay. So the first thing you do, I'm going to just recopy the original problem up here. And I think you probably should too. I know this seems dumb, but let's just recopy the original. Because in a minute we'll have changing it so much that you'll be like, what did it even look like in the first place? All I'm doing is making kind of a copy. If you get the lasso tool on Notability, that's much easier for this than mine. In fact, I think I have a way to just straight up copy this. And I just missed it. Undo that. If I just want to copy something. There. There. I can copy stuff. Yay. Okay. Move it over here. Okay, so now, the big reveal. This part disappears. Why? Because you absolute valued all those negative numbers, they can't be there anymore. And I get a lot of you are thinking, I'm going to reflect that over to the other side like we did before. Nope, that doesn't happen. So what you do instead is I'm gonna make you think through what a function does. Do you get if I stuck in my function, I stick in 1 in my function, it spits out this, which might be at like 2, because this is 1 comma 2. If I stick in a 1, it says the answer's 2. If I stick in a negative 1 into my function thinks that I put in a positive 1. Watch. Because if I absolute value it, then when it comes out of the absolute values, it's just like I had put in a positive 1. And so it says, oh yeah, the answer's 2. Because it thinks I put in f of positive 1. So then it's going to say the answer's 2. When I put in a negative 2, what's the function going to think I put in? Positive 2. So it'll think I should give this answer of 0. Do you see what's happening here? And now when I put in negative 3, it's going to think I put in positive 3. And so it's going to spit out this answer. And do you see that it's just going to copy it over? Now, I know that's confusing. It always is every year. Some of you caught the explanation and some of you didn't. But at a minimum, if you can understand that this side now will have exact, perfect, even symmetry, also known as y-axis symmetry, with the other side. So it looks like a W. And that's it. That's what the green looks like. In fact, just to make it extra clear, make my final answer green. You won't be forced to explain why it does it. But one last time, I like to think of it as when you put in a negative number like -3, it absolute values it right away, and then it acts like you put in a regular 3. Figures out what answer it should spit out, and it spits out the same answers as if you had given it a positive. Okay. So now, let's see if you've really got this. I'm going to give you a function, and I'm going to ask you to, let's make it like the upside down baseball cap. And that's f of x. Now I'd like you to do, there's 2 ways you could do absolute values, right? Let's do the way we just practiced, where you take f of x, but you absolute value only around the x. Do that. And I know you're going to kind of want to keep the original, so if you want to, you could like take a copy of the original and slide it over so you can see the original question. But then erase out the part that has to be erased and draw your final answer. And then turn it my way, and I'll tell you if you did it right. Pause for a second while I check some. So, I got most people getting this right, but here's the first step. Did I wipe out all the negative x's, or should I wipe out all the negative y's?
X's.
I should wipe out all the negative x's. So there they go. They're gone. And then, this is the kind where it feels like you should reflect that over to the other side, but then it wouldn't really be a function anymore because it wouldn't pass a vertical line test. And now that is not perfect, but it's supposed to have a line of symmetry. Being the y-axis should be a line of symmetry. So I'm going to try it one more time, just see if I can make it a little more symmetrical. There, about like that. Raise your hand if you had that one right. Okay, good. Now here's one more to practice the other way. Here's a function. It's just a normal parabola, except it's shifted over a little bit. Its vertex isn't right on the y-axis, you know? Okay, if that's f of x, what would be the absolute value of f of x around the outside? This time I want you to show it to the kid next to you. You can use the technique of just scribbling out the part that doesn't exist anymore because it got moved. Or you can erase it out, whatever. And in a moment, actually the best way to do this is to hold yours up side by side to theirs. Like if you hold your iPad out and they hold their iPad out, and you can look at them side by side, you can see if your sketches kind of look the same. I know it takes a smidge more work, but it's not that much more work. If you put them side by side, you'll be able to tell. And some people are not going to be doing it right, because some people will be doing the wrong kind. The y's are being affected, you know, because the y's that were negative all of a sudden became positive. I'm seeing lots of right answers. You're doing it right. Just like that, you were doing it right. All right, so where are the y's that were negative? They were down here. That makes sense that they're gone. Those are where the y's were negative, and we just absolute valued all the y's. And so now they go up here. That's not perfect, but that would have been good enough on the test. Raise your hand if you had that one right. Okay, good. Yay. Now, the only thing that's left is that sometimes they don't give you the picture. Sometimes they give you, here's a parabola that's been shifted. Well, let's talk about it. Which way has this parabola been shifted?
Right 4.
Right 4, down 6. Everybody sketch a parabola that's been shifted right 4 and down 6. It doesn't have to be perfect. Just kind of quick sketch a parabola and then drag it to the right 4 and down 6. Do you kids a lot like what we just had a second ago? And then what if they said, let's put the bars around the whole thing? Now what would we do? If we just put the bars around the whole thing, we put it around f of x. Couldn't it be kind of like I just put it around y? Because y equals that, right? See what I mean? So when we put the bars around the outside, then that means all the y values that were negative just got torched and they get replaced. And there we go, something like that. What's the other way I could have done it? Could have taken the same exact problem. Y equals x minus 4, quantity squared minus 6. And what do you think I'm going to do next?
I'm not sure.
I can absolute value in a different way. Instead of around the outside, just around the x. So wouldn't you want to graph it first? Yeah, before you even do the absolute value, you want to graph the original one, right? So again, it's a parabola, shifted right 4, down 6. Maybe it looks something like that. And now I'm going to have to move it. Oh, wait, no. I'm going to have to absolute value all the x's. So all the x's that were negative have to go. These would leave. And it would look something like that. How many of you followed that? Okay, not that many. So I'm going to try one more like that. I'm going to give you one more, and it's going to be a nice simple one. Y equals square root of x plus 3. Everybody, just start by graphing that. I think the problem last time is I absolute valued too quick. Everybody just sketch this. You should be able to sketch these things in your sleep. Just like, oh, you know the parent, I move it, boom, done. First, just compare your original sketch after you've moved it to the kid next to you. Make sure you've got where square roots should be. Got that? Okay, I hope you all shifted it left 3. Get what I'm saying? Is that about right? Now, what if I absolute value on the inside? Did I just absolute value all my y values or all my x values? X values. So all my negative x's have to go away. Which are these? They're gone. I could have erased them, but I'd like to kind of leave it evidence that they used to be there. And then this part. My line of symmetry is off there for sure. Close enough. Raise your hand if you had something like that. Cool. Then you get this stuff. All right. Do you get that there's a critical 24-hour forgetting window? If you look at this again within the next 24 hours, and I don't mean like right this minute, I mean like give it some time, look at it again, and you do a couple, it'll stick way better because it's telling your brain, oh, apparently you're saying you want me to remember this because you did it twice. There's a ton of things you only do once in your life, and your brain is trained to forget those things. Because you get there's a ton of things that happen to you once, and it'll never happen again, and it doesn't matter. So your brain forgets those things. Your brain doesn't know that this is important right now. That seems dumb, but okay. So the way you tell it is by doing some homework tonight, practicing this one more time. Give it some time, and then do it again, and then your brain will say, "Oh, apparently this is way above average importance. I'm going to make this stay in the memory banks." Okay, so do some practice problems, and I'm going to get to them and show you what I would do. if I were you. I'm not going to talk about the partner thing. Here, oh, this is more just notes. Let's get to the homework, actual homework. And here we go. Definitely think you should just do that first, because look what they have you do next. The exact same thing, except they put absolute value bars around it. So if it were me, I'd put that there. And I'd be thinking parabola that's been shifted to the right too, but ooh, also flipped. Ooh, this one's kind of icky. It's been flipped. And do you agree I could move the 4 to the end and make it plus 4 at the end? That might make it easier for you. You'll see that, oh yeah, it's moved to the right 2 and down 4, and it's been flipped. Best advice on flips, do them early. Because it's not hard at all to graph a parabola and then immediately flip the parabola. Do your flips first. Because then it's easy to move it over and down and up. Okay? And once I got it all done, then this will follow very naturally, because you'll have where the parent is already done, and then you go, okay, what's those rules again? I'm absolute valuing around the outside, so that's all the y values. Okay, so let's see. Where do I move this again? 2 to the right, and then up 4. So there's where my parabola's peak should be, and parabolas kind of go over 1 and up 1, and then so there's my original parabola. And by the way, I know some of you are not awesome at graphing. How is this test going to go for you if you're not awesome at graphing? It'll go great if you know how to make an XY chart. Because if you totally forget, oh, I'm getting all confused on my flips and my moves and my stretches and my whatever, well, just stick in a number and see what you get. If I stick in 0, I end up getting -2 squared is, well, wait, there's a negative on the outside, so it's -4 plus 4 is 0. 0, 0 is on my graph. And if you do enough points, you'll be like, oh, obviously the parabola is there. So you can always get points off an XY chart until you get your graphs done. And then, since you guys have the lasso tool on your iPads, there's no shame in just taking a picture of it and moving this down here. And then you'll have to do the tweak to it. Oh, absolute values on the outside. Apparently I take the y values that were negative and I make them bounce up into be positive. Okay. All right. Practice this tonight, and this could be one of your easy ones for the test. I think you guys are getting this pretty well. If you make it stick by doing a little bit of homework for practice, I think this could be a happy place when we eventually test on this stuff. Yes?